Hi students, let's have a look at this quadratic equation and solve it. Well, so we need two numbers that multiply to 10 and add to 7, and those two numbers are certainly 5 and 2. So we can rewrite this quadratic equation as x square plus 5x plus 2x plus 10 is equal to 0. Now I can factorize this as x into x plus 5. And again, I write x plus 5 here, and plus 2 equal to 0. So I get x plus 5 and x plus 2 equal to 0. So the value of x is minus 5 or minus 2. So they are both the roots of this quadratic equation. Now let's look at a slight variation. Instead of x square plus 7x plus 10 is equal to 0, I'm just making a small modification. Instead of plus 7x, I am doing minus 7x. I've just changed the sign of the linear coefficient. Okay, so we had plus 7x here. Now we have minus 7x. Everything else remains the same. Now we need to find two numbers that multiply to plus 10 and add to minus 7. Okay, so what are those numbers which multiply to plus 10 and add to minus 7? They clearly are minus 5 and minus 2. Okay, just a second. Okay, so I can rewrite this quadratic like this: x square minus 5x minus 2x. They add up to minus 7x. And then minus 5 into minus 2, they add up to 10, plus 10. Okay, so now let me factorize this: x square x minus 5 and x minus 5. And then I have minus 2 here. It's equal to 0. So the two factors of the above quadratic equation are x minus 2 and x minus 5. So the value of x is 2 and 5. These are the two roots. Okay, so till now we saw two forms of the quadratic. One in which all the terms were positive, and the second one where the linear term was negative. Now let's look at another variation. Here the linear term is positive, but the constant term is negative. Till now we never did a quadratic with a negative constant term. Now we'll do it. So now we have to find two numbers again which multiply to minus 10 and add to plus 3. So since the constant term is negative, it means that only one of the numbers can be positive. The other has to be negative, because only then you will get a negative constant term. So what can those two numbers be? Again, we can either have minus 5 and 2 or minus 2 and 5. Both of them will give us minus 10. But if we want plus 3x, then the smaller number 2 should be the negative 1 and the larger number should be positive. So minus 2 and 5 are our numbers. So now I can rewrite the above quadratic as x square minus 2x plus 5x minus 10 equal to 0. So minus 2x plus 5x will give me plus 3x. Now let me factorize this: x square minus 2x And then I have x minus 2 here again. And plus 5x minus 10 equal to 0. So the two factors of this quadratic equation are x minus 2 and x plus 5. They both are equated to 0. So the value of x is going to be 2, 2 and minus 5. I hope this is clear now. So the next step we'll do is, yes, you guessed it, we will make both the linear term and the constant term negative. X square minus 3x minus 10. Now here again the constant term is negative, so we need one number to be negative and the other one to be positive. But then the linear term is minus 3x. So of the two numbers, again 5 and minus 2, of these two pairs, the first pair is 5 and minus 2, the other pair is minus 2 and 5. Clearly, I'm sorry, this is both the same. Yeah. So clearly, I need this pair because this will not only give me minus 10, but will also give me minus 3x. Whereas this is going to give me plus 3x. I don't want plus 3x, I want minus 3x. So the above quadratic can be rewritten as x square minus 5x plus 2x minus 10 equal to 0. And I can factorize this as x square minus 5x and again x minus 5 I'll write and put plus 2 is equal to 0. So the two factors of this quadratic equation are x minus 5 and x plus 2. I equate both of them to 0, and therefore the values of x are 5 and minus 2. So you see, students, how I have taken 4 quadratic equations. The last one, except the x square term, all other terms were negative. And then I took another one in which the linear term is positive and the constant term is negative. And then another one where the linear term is negative but the constant term is positive. And another one in which both the linear and the constant term are positive. And we saw that in each of the cases, the roots involve the numbers 5 and 2, but the signs are different. So I hope now you realize how to find the pair of numbers for different types of quadratic equations where the signs of the different terms are different. They vary. So I hope this is clear to you now. If you have any questions, you can ask it in the comment section. Thank you very much.